Solve this trig inequality. Sine 2x is greater than or equal to negative 2 cosine squared of x over 2 plus 1. And we'll solve over the domain from 0 to 2 pi. Well, the first thing we're going to do is move everything to one side. So we'll have sine 2x plus 2 cosine squared of x over 2 minus 1 is greater than or equal to 0. At this point, we can tell what we want. We want the positives or 0. Why do we want those? Because this expression is greater than or equal to 0. Now what we're going to do is switch this inequality to an equal sign. We'll find all the zeros, and then we'll set up a number line. So sine 2x plus 2 cosine squared of x over 2 minus 1 equals 0. Now right now we don't like this because this has a 2x and an x over 2. They don't have the same argument, or in other words, they don't have the same angle, and so we're going to need to use our identities. There's two ways to go about using an identity for this one here. We could start off and just say cosine of x over 2 is plus or minus the square root of 1 plus cosine x over 2. So let's just do that. And we'll have plus or minus square root 1 plus cosine of x. Let me write it properly. All over 2, and that's inside the radical. Quantity squared minus 1. And there's only one identity for sine 2x. That is 2 sine x cosine x. And we'll put that plus there. Now if it's positive or negative and we square it, we're going to get the exact same thing. So we'll be left with 1 plus cosine of x over 2, and we'll have that 2 on the outside, minus 1. The 2's will reduce. 1 plus cosine x minus 1, or in other words, just cosine x. And we have our 2 sine x cosine x all the way down. Now this becomes just like what we've solved before. But before I go on, let me take a look at another way we could have done this. When we were working on our identities in section 3, we had one, I'll do this over here on the side, that said 2 cosine squared of theta minus 1 equals the cosine of 2 theta. Well, in this case, theta is x over 2, and so that will give us cosine of 2 times x over 2, which is just cosine. So in this particular problem, since we have 2 cosine squared minus 1, without that minus 1, it wouldn't have been, we couldn't have done that. We could have gone straight to cosine x. Now to solve this, we realize we have a common factor, so let's take it out. Cosine of x times 2 sine x plus 1 equals 0. Set both factors equal to 0. So we have cosine x equals 0 and sine x equals negative 1/2. Take a look at our unit circle. Cosine is x on our unit circle. If x equals 0, we're looking at this vertical line. There are two solutions there. X will equal pi over 2 or 3 pi over 2. Sine is y value, and y equals negative 1/2. If this is 0 and negative 1, here's negative 1/2. What are those two values? Always try to think along, and can you tell me those before I write them? 7 pi over 6 and 11 pi over 6. Now the other one we need to consider is there anywhere where in the original either function was undefined? Is there any place where it didn't exist for any x value? We're dealing with a regular sine and a cosine squared, so no, there's no undefined values. Now we can go to our number line. I'll move it up here a little bit. We'll have 0, and we need to put them in order. The spacing of it doesn't matter. Pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6, and then 2 pi. And we have zeros at all of those, those 4 values, because that's how we found these. There are zeros of this equation. Now we need to determine, is it positive or negative in each interval? Well, we're going to do this one without our calculator, so we need to pick a number in every interval. In this first interval, let's start with x equals pi over 3. Now we could have picked pi over 6 or pi over 4, but if we picked pi over 6, we would have found if we plugged it into x over 2, then we would have had x over 12, and we don't know what that one is. This is going to be the easiest one. So we have sine of 2 pi over 3, that's coming from here, 2 times pi over 3, plus 2 cosine squared of x over 2. If x is pi over 3, divide that by 2, and we'll get pi over 6 minus 1. So we need to simplify this. The sine of 2 pi over 3, that would be in our second quadrant, has a reference angle of pi over 3. That would be root 3 over 2. Cosine of pi over 6 is square root of 3 over 2, and we're going to square that. So that would be 3 over 4. And then we're going to multiply that by 2, so that would be 3 halves. And then the minus 1 is just carried over. Is that number positive or negative? Well, 3 halves minus 1 is positive, and this is a positive, so that will be a positive number. Write it over here. So we'll put plus. Now we need a number between pi over 2 and 7 pi over 6. What's the easiest one? Pi. Because now we can say the sine of 2 pi plus 2 cosine squared of pi over 2 minus 1, and the sine of 2 pi is 0. Cosine of pi over 2 is 0. So if we square that and then multiply by 2, we still get 0. And then minus 1, so this time it's a negative. The next interval between 7 pi over 6 and 3 pi over 2, I would pick another value that's over 3, and in this section it would be 4 pi over 3. So we'll have the sine of 4 pi, no, the sine of 8 pi over 3 plus 2 times cosine squared of 4 pi over 3 minus 4 pi over 6. Let's see, 8 pi over 3, that's going around the circle a full time. That would be 6 pi over 3. And then it goes up to 2 pi over 3. And we know that that one is the same as we did earlier. That's square root of 3 over 2. That's positive. 4 pi over 6 is the same as 2 pi over 3. The cosine of 2 pi over 3 is negative 1/2. When we square negative 1/2, we'll get positive 1/4. We multiply positive 1/4 by 2, and we get positive 1/2. And then we're going to be subtracting 1. Now, square root of 3 over 2, as you recall, is about 0.86. Plus 5 gives us 1.36-ish minus 1, and this will give us a positive number. So we can just put plus. Now we need a number between 3 pi over 2 and 11 pi over 6. So we'll use 5 pi over 3. We'll have the sine of 10 pi over 3, 2 times 5 pi over 3, plus 2 times the cosine squared of 5 pi over 6 minus 1. 10 pi over 3, again, we're going to have to figure that out going around the circle. It goes around 1 complete time at 6 pi. over 3, and then it goes another 4 pi over 3, and that puts us in the third quadrant. And in the third quadrant, we'll have negative root 3 over 2. 5 pi over 6 is in the second quadrant. It has a reference angle of pi over 6. Cosine of pi over 6 would be square root of 3 over 2. In the second quadrant, it's negative. When we square that, we'll get negative square root of 3 over 2 squared will be 3 over 4, multiplied by 2, and we'll get positive 3/2. And then minus 1. Again, this number, root 3 over 2, is about 0.86, so we have a negative 1.86 plus 1.5, and this will give us a negative number. And the last one, there is no value on the unit circle between 11 pi over 6 and 2 pi, but we're going to fudge it a little bit, and we'll use 2 pi. Since that's not a 0, then it's not technically in our region, our interval, but that's okay. So now we'll have the sine of 4 pi plus 2 cosine squared of pi minus 1. 4 pi, sine of 4 pi is 0. Cosine of pi is negative 1 squared is positive 1 times 2 is plus 2. And then we got minus 1, and so it's a plus. Now we have to look and see, what did we want? We said we wanted the positive or 0. Positive or 0. So we just look at our interval, and we'll say between 0 and pi over 2, including the endpoint, so we'll have brackets, union 7 pi over 6 to 3 pi over 2, close, union with, bracket 11 pi over 6, and 2 pi will be a parenthesis. And that pretty much is the hardest type of problem that we'll be working on. If we had a graphing calculator, or a calculator I should say, we could pick any number in there and just type it in and see if it's positive or negative. I want to make sure that you can do this without your calculator, that you actually understand what's going on. That's it.